Practical uses of free body diagram. Understand component interaction with its neighboring components. Quick component analysis instead of multi-component analysis. For example, let us consider a helical gear transmission system. In order to analyze the shaft stresses, the entire system need not be modeled. The free body diagram at a given instant provides all the loads acting on the shaft to carry the stress analysis. This leads to a significant amount of computational saving. Note that helical gears are subjected to 3 loads, namely tangential, axial, and separating. At the left end, ball bearing is used for axial restraint. It supports both radial and axial loads, whereas roller bearings at the right end support only radial loads. In many situations, to facilitate finite element analysis, certain loads such as friction, air or gas loads, centrifugal loads could be found via free body diagram. Many simple components such as pulley, ropes, brackets are standardized for stress margin via hand calculation with the use of free body diagram. Free body diagram can be applied to large idealized structures to get a basic idea about stresses and deflections.